Okay, find f if f prime of x equals 4x cubed plus 2x squared minus 9. Well, this one, this problem, it isn't directly stated, but think about what we're wanting. I've got the derivative is this, and I want the f. I've got the derivative, I want to back up, in essence, to find the function f that comes from. So don't I want an antiderivative here? That's an antiderivative. I've got the derivative, so I want to get the antiderivative to back up to the function, if you will, all right? Yeah, so f is the antiderivative. So it's the antiderivative process. Take the 4 times the antiderivative of x cubed. That would be x to the 4th, 1/4 times x to the 4th, which that's going to be good. The 4 is going to cancel. Plus the antiderivative of 2x squared would be 2 times, add 1 so you got x cubed, so it's 1/3 x cubed is the antiderivative times the 2. With a constant, you do the antiderivative, you add the x. And we are wanting the most, f in most general terms, so we add the plus c, so what does that work out to? The f of x would be, the 4's cancel, it's just x to the 4th, plus 2/3 x cubed minus 9x plus c. Okay? So it's really the same problems we were just doing, it's just wording it a little slightly bit different. Now, find f if f double prime of x equals 18x squared. In this case, we are given the second derivative. So what is that going to mean to find the function if you've got the second derivative? Well, basically what it means is I've got to back up 2 steps, right? If I've got the second derivative, if I do the antiderivative of it, that's going to give me the first derivative, because that's just 1 step closer, if you will. So the antiderivative of the second derivative gives me the first derivative. Does that make sense? All right, what would that be? The antiderivative, I've got 18, the new power would be x cubed, so divide by the 18 by 3, so it would be 6x cubed plus your constant. So I want to do an antiderivative again to get to my function. So now I've got the first derivative, so I do the antiderivative, it gives me the function f. Well, what is function f? Well, it'll be 6 times 1/4 x to the 4th, right? Now, I've got this constant c, so what happens when I have a constant? For the antiderivative, you add an x, right? So I have cx, because the first derivative gave me a constant, so when I do the derivative of it, it's going to give me a cx. But, don't I have to add a constant to this one? Now the thing is, does it have to be the same constant that I had in that one? No. It can be a different constant. And so we'll just denote it as it's d. Those could be 2 separate, probably are, 2 different numbers. So it just cleans up to be, what, 3/2 or 1.5? 3/2 x to the 4th plus cx plus c. All right? Okay. All right. Now let's do a couple others and add another step onto this. So let's find f if f prime of x equals 2x plus 3 and f of 2 equals 4. So you can see I've got a little bit more information, and I'll tell you what that means to us here in just a second. All right, so I've got f prime. So again, I've got the derivative, so I want to back up. So I need to do the antiderivative here to get the f. Well, it's 2x, so that would be 2 times, well, the new power would be x squared, so I'd divide by 2, or half x squared. I'd add an x to the 3 there, and then a c plus c at the end. So I've got f of x equals x squared, 2's cancel, plus 3x plus c. All right, here's what this information gives me. If I know a little more about the function, I can actually figure out what c is. And so that's what this information does, is it gives me the values so that I can figure out what actually the c value here it is. So I've got a specific function in mind with a specific number here, and I can find it by plugging in the given information. Well, f of 2 equals 4, which is which? Well, the 2 here is inside, so that's the x, right? And then the 4 is the f of x, the function value at x is 2. So I'm going to plug in x to be 2 and f of x to be 4. f of x is 4, x is 2. And yeah, it's a simple, all you really have to do is subtract the numbers. You got 4 equals 10 plus c, so it looks like subtract 10. C is going to be a negative 6. So the answer that they want is f of x equals x squared plus 3x, and then minus 6 for the c. Yep. Okay. So one more of those where we do this. All right, so let's find f. If f double prime of x is cube root of x plus 128 over x cubed, f prime of 8 equals 0, and f of 1 equals 7. Okay. So again, two other bits of information. So we start with the second derivative. So our antiderivative of it gives me the first derivative. Of course, again, I probably want to write that as x to the 1/3 plus 128 x to the negative 3 for antiderivative purposes. Because that x to the 1/3, the new power would be x to the 1/3 plus 1 is 4/3, right? And so the number in front would be the reciprocal of that, 3/4. The 128, x to the negative 3, so the new power would be x to the negative 2, because you're adding 1. So I divide by negative 2, 128. And then I have the plus c. 3/4 x to the 4/3 minus 64 x to the negative 2 plus c. Well, I can do that one better because I have f prime of 8 equals 0. That tells me when x is 8, f prime of x is 0. So I can plug those in and figure out what c is. So f prime is 0, 3/4, so the x is 8. 8 to the 4/3 minus 64 times 8 to the negative 2 plus c. What goes in? Works out pretty nicely. 8 to the 4/3, that's cube root of 8, which is 2 to the 4, that'd be 16. 8 to the negative 2, that's 1 over 8 squared, which is 1 over 64, so what does this become? You got 64 times 1 over 64, that's just minus 1. 3/4 of 16, see the 4 would cancel, so you have 12. So 12 minus 1 plus c, That's 11 plus c, so 0 equals 11 plus c, so it looks like c is negative 11. Here. So f prime of x turns into 3/4 x to the 4/3 minus 64x to the negative 2 minus 11. But I'm interested in f, so I got to do the process one more time. Antiderivative. Take that antiderivative. So we'd have 3/4 x, the new power, what's the new power? 4/3 plus 1, 7/3. So I'd multiply by the reciprocal here, 3/7. Then I have minus 64. X, new power would be negative 2 plus 1, which is negative 1. So I divide by negative 1. 1 over negative 1. And then I have minus 11x. Then I need another constant, call it b. We use the other one as c. Clean that up a little bit and then we'll finish it up. What was that? 9/28 x to the 7/3. Minus 64 divided by negative 1 plus 64 x to the negative 1. Minus 11x plus b. But I've got f of 1 equals 7. So that would be x is 1, f of x is 7. What goes in? F of x is 7. And that was nice here. It said x is 1. So 1 to a power is 1. So that's going to be 1. 1 to the negative 1, that's going to be 1. 11 times 1. Yeah. So I've got 7 equals 9/28 plus 64 minus 11 plus b. Let's do this. Let's just subtract. Let's subtract 9/28, subtract 64, and add 11 over here to the, well, both sides, but it's where to wind up, right? Subtract 9/28, subtract 64, and add 11. Let the calculator do the work here. 7 minus 9/28 plus minus 64 plus 11. Negative 46.32. See what that is as a fraction. Negative 1297 over 28. That's my d. It didn't quite turn out. Whole number there, integer. All right, so my final answer, plug in that for d. 9/28 x to the 7/3 plus 64 x to the minus 1 minus 11x minus 1297 over 28. Lovely little number there. Okay. Yes?